All right, this is part 3, section 2.2. We're looking at organizing quantitative data. We were looking at this question right here of wait times, and we are on part F. We want to construct a frequency histogram of the data and then construct a relative frequency histogram. So I'm going to come over here and I'm going to go under graph. So I've got all my data here in StatCrunch. And then I'm going to go to a histogram. It's going to be based off of wait times. So this is when I have the raw data. So 11 for one Saturday, 4 for the next Saturday, 13 for the next Saturday, so on. And okay, first I need a frequency, and this bin kind of tells me how to set up my classes. And if I don't put anything in here, what it's going to do is it's going to, kind of analyze the data and make its best guesstimate on what it what class sizes. So notice this class size right here has a frequency of 2, and that's going from 2 to 4, but not including 4. And then the next one goes from 4 to 6, but not including 6. So these have a class width of 2. And if I wanted to change that, I could say, well, I want a width of 1. If I change that, then now notice that these widths right here are going from 3 to 4, 4 to 5, 5 to 6, and so on. So you can change that, and then you can always come in and put the value above, so you can see the values there. So that would be the frequency histogram. And then to get the relative frequency, I'm just going to hit Options. I'm going to edit this, change it to relative frequency, and compute. Okay. And then again, if you want to stretch it out to get it bigger, to make your graph look bigger, you're always welcome to do that. But that's how you do that. And then again, to change your class widths, you can just come in here and you can tell it whatever size, and it's going to create those for you. So here are the frequency and the relative frequency. I've just taken a snapshot of each with the class width of 1. And the last thing is describe the shape of the distribution. Okay, so if I want to describe the shape of the distribution, notice that we start here and then we peak out high, and then it starts to taper off. And so at first glance, it might look like this is a skewed right, but or you might have seen it as a bell curve. This one is probably a little bit more bell curved or symmetric than it is skewed. And sorry, I'm trying to get my pencil to work. My iPad just froze completely. So I'm going to have to pause, bring my iPad back to life. Okay, so we've brought the iPad back to life here. But if I were to draw a shape of this, it's pretty rough, but it would probably be best outlined. My best estimate would be a symmetric graph. If you saw it as skewed right, you could definitely see why that is, because you have some numbers tailing off here. But probably the closest it would be symmetric. But later on we're going to learn some techniques to find out, is it actually symmetric? Like, how close to symmetric is it? Okay. So another way to represent quantitative data graphically is what's called a stem and leaf plot. And so here's how this works. In a stem and leaf plot, sometimes you'll hear it as a stem plot, we use the digits to the left of the rightmost digits to form what we call the stem. Okay, so I'll give you a picture of this here in a second. And then each of these, what we call rightmost digits, is what we what forms a leaf. So, for example, if we wanted 147, we would have a stem of 14 and a leaf of 7. So you would do something like this. You do 14, and then you draw a little vertical line and a 7. Or sometimes you'll see it'd be 14 and a colon and a 7. And this would represent the number 147. But then if you say you had in your data set you had 147, you had 149, 149, 143 or something like that, then you would just continue to add on, and you would probably want to do this in ascending order. But what this means is I have 147, I have 149, I have 149, 143. So that's what the stem and leaf does for us. And it kind of helps us see the distribution on, kind of turned on its side when we do this as well. Okay, but let's just look at this one. We've got the data for the age of inauguration. So all of this data represents the age of presidents of the United States from George Washington through Barack Obama on their first day of office. And there are a couple of ages that are for presidents that are listed twice. 47 and 55, because President Cleveland, his age is listed there twice because he was counted as two different presidents, president number 22 and number 24, since his terms were not consecutive. So that's just a historical note. But if we wanted to do a stem and leaf, okay, usually what's good to do here is to order your data from smallest to greatest. But I'll just give you an example. So like the first one's 42, so I'd do 4 and a 2. And then 43, so I'd add on a 3, 46, 46, 47. Then jump back to the top, 47, 48, 49, 49. And then 50. I'll put a 5, so it'll be 50, 50, 51, 51, 51, and so on and so forth. And then you'd have to give yourself a key, like you'd put something like this at the bottom to say that that represents 50. And it's just a quick way of putting all of our data together. So I'm going to put together a stem and leaf plot in StatCrunch, and StatCrunch kind of breaks things down a little bit tighter. It'll cut it off at in the middle here, but just to give you an idea. So come over here. Let's see, did I have one with the ages of the presidents? Did not. Let's see. Okay, so here are the ages of the presidents. I'm going to do a graph, stem and leaf, by age, and then I will hit calculate on that. So here's the stem and leaf. So you can see 42, 43, and then 46, 46, 47, 47, 48, 49, 49, then 50. StatCrunch breaks them down. Again, it cuts it down in the middle. But if you look kind of on its side, you can see, if you were to kind of trace, this looks pretty symmetric. And that's one of the big advantages of a stem and leaf plot, is it kind of gives you a histogram, just in a different form. Okay. So that would be stem and leaf. Okay, lastly, if you have a dot plot, okay, this is the last one we'll look at. So you can draw a dot plot by placing each observation horizontally, increasing in order, and putting a dot above it. So I'm going to be kind of quick with this one, so I'm running out of time. But you have 0, then you have 1, then you have 2, and 3, and so on. And so every time I had a number, so like here's 1, so I'd kind of cross that out, and I'd put a dot for 1. And then I'll do 1 again, so I put a dot for 1. And the key here is you want to space these things evenly. So then 4, so I want to make sure 4 is here. So I wouldn't, like, if there was another 4, I wouldn't want to put the second dot here, because then that would skew things. I want to try and keep, you know, everything level. So all the 2s are here, all the 1s, airballed there, but you get the idea. But that would be the dot plot. So then you do a 2, a 3, another 3, 5, and so on. And this will look like a histogram, but it's just made out of dots. And so, you know, that's the dot plot. Very straightforward, so I won't spend a lot of time on that. But that's a look at this section, all the different ways, well, some of the most popular ways that we can represent data that is quantitative.